Good afternoon, everyone. Welcome to Dreamforce 2016, and thanks for joining us this afternoon. Our session is going to be our introduction to Apex Callouts. I'm Sai.
Hello, everybody. I'm Sagar here. So thank you, everyone, for joining us. And we are going to take you through a journey of Apex Callouts. So have you ever thought of connecting to a data that doesn't reside on your org, but resides somewhere outside? Here, we are going to take you through a journey to implement Apex Callouts and see how easy and how efficient is it to actually implement Apex Callouts within your Salesforce application. Over to you, Sai.
Thank you. Let's start off with understanding what an Apex callout is. The ability within Apex to invoke an external web service and get data to be displayed within your Salesforce application is called as a callout. In other words, if you want your Salesforce application to connect to Google, Facebook, Twitter, to try to get data from these external web services and get it displayed in a way that you would want to enhance the working process of your application, then callouts is your answer. The image below kind of describes the entire flow in an Apex callout. From within your Salesforce application, you invoke a request. You try to reach out to an external web service, trying to either retrieve information, trying to post information, depending on what your application would want to do. The web service would parse your request, depending on what you're trying to retrieve, and then it would come up with a response, which again is sent back to your application. On the application side, you have the liberty to do whatever you want with that data and get it displayed back. This is a good point to also talk about what an Apex web service is, because the name gets confusing. Apex web service refers to the method by which Salesforce applications are exposed to an external application. So in other words, it can be referred to as a call-in. So a callout is referred to as the process by which Salesforce is invoking something external, and then call-in is something where an external application is invoking a service exposed on your Salesforce organization. Now that we know what an Apex callout is, let's try to understand when to use callouts. On a day-to-day basis, there are a lot of use cases where we would want to connect with external organizations, where we'd want to connect with external data, and we'd want to basically consume the data, parse it, and then display it in the most appropriate way. In those cases, callouts would be the most handy tool. We came with a couple of common use cases that are being used across the organizations these days. The first is a product sentiment analysis tool. Let's say your organization has released a product and you would want to guide your sales reps to decide the pitch that they want to go forward with. The most easiest way is to try to understand the trend from Twitter, Facebook, or any of these social media sites. So you can build a tool where from within your Salesforce organization, you're trying to invoke, let's say, Twitter's API, trying to understand what the customers feel about your product, and then based on that, you can help your sales rep change the pitch or help them try to understand what the customers are expecting and basically make a decision based on that. The second common tool is emergency alerts tool. Let's say you want to alert your employees whenever there is an emergency news that comes up in one of these news sites. Again, you can integrate a component on your Salesforce application. You can connect to one of these news sites APIs, trying to parse the data, and then display it in a way that is most appropriate for your organization. So these are some of the common use cases about when you can use Apex callouts. Let's try to hear about the methods for which you can use these callouts for.
Thank you very much, Sai. So we have been hearing more about web services. So how do they relate to the Apex callout discussion that we are having today here? So let's take a look at the comparison that we have done for SOAP versus RESTful APIs. So what does SOAP stand for? SOAP stands for Simple Object Access Protocol, while REST stands for Representational State Transfer. SOAP is a protocol, while REST is an architectural style. SOAP uses something called as a service interface to expose its business logic, while in REST, we use Uniform Resource Identifier, that is a URI, to expose business logic. SOAP uses more bandwidth and resources, while we can see REST is more advantageous, which requires less bandwidth. SOAP is quite strict with its XML data formatting only option, while REST is kind of flexible. We can see here REST can use XML, JSON, HTML, and even plain text. So, but how do we actually relate to the Apex callout discussion that we have? We compared SOAP versus REST, but how do we actually use it? Let's take a look at it. So based on how the external web service is exposed, we should be able to decide whether are we going to use the RESTful APIs or the SOAP web services. So we are moving into an era where majority of the web services that are exposed through RESTful web services. So there are different classes available to us, including HTTP, HTTP request, HTTP response, which actually gives us an option to reach out to the third-party APIs, get the data, and then parse it and put the response in a format that we or our customers would like to see. How about if the external web service is exposed as a SOAP web service? Great. Salesforce actually gives us a tool, which is WSDL to Apex, which actually creates the Apex classes from the WSDL definition that is available to us. The XML generation, data transmission, parsing is all handled automatically, and you don't have to worry about it. Let's dig deep into it and find out what are the different methods available in these classes. Over to you, Sai.
So if we go back to the image that we saw in the first slide, the Salesforce application invokes a request, and then we get a response back. So a request contains certain important components that are essential for the endpoint to parse and respond back. So these are some of those important components that are required for a successful callout. The first part is the HTTP request, which is an Apex class that is used to initialize the external web service callout call. The second is the endpoint. The endpoint here refers to the location where the REST API has been exposed. So depending on what we are trying to achieve, the URL in that endpoint would basically change. The next is the method parameter. There are different parameters related to that, but the most common ones are the get and the post. There are other parameters like head, delete, and other things. So based on this example, we are trying to post something into the external web service. Hence, it is the post method. The next component is the header. The header basically contains the operating components for the transaction. In this case, we are trying to send out a JSON content. Hence, we set the content type as application and JSON. Next is the body. Body, again, depends on what we are trying to achieve through the transaction. If it is a get, then usually we send out an ID. If it is a post, we are trying to enter the details that has to be inserted into the application. Finally, it's the timeout. Timeout is an important component because it lets the application know how long before it gives up on the response from the external web service. So these are all the essential components that needs to be filled out for an HTTP request. And this would give the external web service an idea about what we're trying to achieve. Now that we know what a request is, going back to the image that we saw first, what we need now is a response. For initializing a response, the HTTP class is your go-to place. You create a new instance, and then you try to send across the request that was created before. On sending this request, the external web service would basically decompose what is being sent across for the application. It would try to read the values that are being set on that request and basically come up with a response. The response has multiple components, and it has methods which are similar to the request. But what really matters are these three: the body, the status, and the status code. The body is out for the application to decide. If you're trying to give back a response that contains JSON values, then it will be content that will be filled out in the body. If it is just a yes or no, if it is an ID, it really depends on what the application is trying to send across. So the contents on the body is what would be parsed and displayed back on your Salesforce application. Next is the status. The status is just a string value, so it can be as simple as a success or a failure. It can be as complex as containing a bunch of values which needs to be understood by the Salesforce application and then reprocessed before displaying it back. Finally, the status code. The status code is usually the values that are being filled out in line with the HTTP codes: 200 OK, 404 not found, and so on. Now that we have a good perspective of what an Apex callout is, when to use Apex callouts, what a request is, what a response is, how to fill out these values, let's do a quick demo about one of the applications which does this Apex callout from Salesforce.
Thank you so much, Sai. So here we are, and are you guys, first of all, are you guys excited for the demo now? Yes, there you go. So here we are, and we are trying to see that we have this page here, which actually looks a little disrupted, but I made it on purpose just because I could show how you can actually add a component to your page. All you can see here is this is an account page, and on the account page, you are actually able to see something on the side, which I'll come back to it in a minute. Let me show you how I was able to add the Lightning component. So what is a Lightning component? So basically, a Lightning component is a component that you can either use standalone or you can embed in one of the pre-created pages. So here we see that we already have a component attached to it. So let me remove one of these components and then save this page. Let's see how it looks now. Let's go back. Let's take a look at it. So all we are trying to do here is on a 5,000 feet view. Here we see that there is an account page. There is something here on the side, which I'm not too sure why I still see this. Let me just go and edit the page. Let me activate this page. I think I forgot to activate it. Let me save it. Let me go back. Yep, there you go. I was finally able to save it. Thank you so much for your patience. So what we are trying to do here is you are able to figure out that in the neighborhood is a component where you are able to find out something in your neighborhood. I would still not reveal what that is, but I think you guys have already found out what I'm going to find it out here. The use case that we came up with while doing this demo was that think about an account executive who wants to meet his client, who wants to take him out for lunch or for dinner to a best fancy restaurant that's available nearby. How would you do it? So here is presenting to you the component in the neighborhood, which would help you easily figure out what restaurants are nearby. So let's think about an account executive who wants to take out his client for a sushi lunch. Let's see here. What happens if I search for some sushi places nearby? Yay, it works. So we are here figuring out different sushi restaurants that are available near to this account. So all I can do is also go here, look at the different options available, and also read about a review, which will help me decide whether I should take my client to this location or not. Isn't this really cool? I mean, finding it out on your account page. So this component is actually really helpful. But now let's come back. I know everybody here might be hungry because it's the lunchtime, and this app is the perfect search for you to look out for the lunch places around. But wait, we are still talking about Apex Callouts, and I'm not diverting you guys. So let's talk about Apex Callouts now. So thinking about Apex Callouts, what exactly is happening here? As you can figure out, we are using the Yelp web service that is exposed to, that is free for everybody of us to use. So all we are trying to do here is add this component onto your account page and take a look at this record ID here. So this Yelp service is trying to capture the record ID that the page is currently pointing to and go figure out the details that, let's see, do we have? Yes. So we do have a billing address here, which is actually showing you the places around San Francisco. So it's going there, grabbing the address. So Yelp basically exposes a couple of methods. Either you can find out the location using the latitude, longitude, if you have the coordinates ready with you, or you can have the billing address being picked up from the account and fed into the method that Yelp is providing us, and then eventually go grab some responses out of it. So the Yelp service, we presented the record ID, and based on the record ID, we grab the billing address, and based on its address, it is able to figure out where the location is and what are the restaurants nearby. Just to quickly try it out once again, let's try out some Thai places around. There you go. So you are able to even figure out the different restaurants around, and if you want, go read about it, where that is located, what's the address, and what the review says. So since we have talked about this, I think this is a right time for us to go figure out what is exactly happening in the back end. You see everything looks good on the front end, everything is working fine. So let's go back and find out what the code snippet looks like. Over to you, Sai.
Thank you. So now we understand how the Lightning component has been integrated into the account page. So let's quickly do a code walkthrough about how this has been achieved. This is a JavaScript that is associated with the Yelp service. And like Sagar mentioned, there are two ways by which Yelp is exposing the restaurant that it is associated with. So the first one is by address, which is basically this component which is invoking all the restaurants that are in that particular area. You want to zoom in?
From the window, maybe? The window option.
The window option.
The window. Yeah. I don't think it's giving us an option.
Yeah, it doesn't look like it's giving out the option.
Or maybe you'd want to disconnect it and then try.
Let me quickly see if I can zoom in. No, it doesn't seem.
It's okay.
Sorry, it doesn't seem to zoom in as expected.
Let's see if it does.
Does that help?
Works?
So there are three important components here. First one is the JavaScript. So like we mentioned, there are two ways by which the values are being exposed from Yelp. The first one is by address. So you can put in a value that corresponds to an address, and then the Lightning component would invoke the Yelp service to return back the values. The second is by latitude and longitude. So it does mostly the same set of things. So this is where most of the action happens for this particular component. There are three methods listed here. The first one is the get list by latitude, longitude, the list by address, and the get HTTP. The list latitude, longitude is basically taking the content that is being provided on the component based on the values such as the restaurant name and then the corresponding value as latitude and longitude. It's combining those values, and then it's creating a particular URL. Let's talk about the get HTTP method in the end. But basically, it invokes that method, it gets the response back, and then the return list value is being sent across to the JavaScript, which parses the values and then displays it back on the account page. The get list by address almost does the same thing, except instead of the latitude and longitude, this time you have an actual address value, which is being passed to the component and then returns back, which is being displayed back on the page. Getting back to Apex Callouts, the get HTTP method is what does most of the work. It looks pretty simple, but it does a lot of things. Like we saw, there's the HTTP request object, which has the two components here, the set method and the set endpoint. Since we are trying to retrieve values here, this is not a post, this is a get. And then the URL is being basically created based on the method that is being invoked from the component. It can either be from the get list by latitude, longitude, or the get list by address. So depending on that, the URL value is being passed on to the get HTTP method. And then finally, for retrieving a response from Yelp, we're trying to invoke the send method, which returns a particular response. And this response is being parsed back to the JavaScript here, which parses it and then displays it back on the Lightning component. So this kind of gives a good idea about what goes on behind the scenes. The most important thing to note here is we are trying to achieve so much with just 5 lines of code. And that is the power of Apex Callouts for you. Let me quickly get back to the presentation. All right. The next question is, how do we test these out? We've built out awesome Apex Callouts, but the question is, how do you know if something really works? Over to Sagar.
Thank you, Sai. That was a really good demo, right, guys? And also, you were able to see the code working right then and there. So testing Apex callouts, I think this question, I think all the Apex developers here right now have this question like, how do we test Apex callouts? Do we actually have to make a callout to the third-party API every time we test it? So how are we going to achieve it? I know there is a Salesforce standard that requires us to write test classes to simulate the execution of the code to see whether it's working as expected or not. There is also a restriction around 75% of the Apex classes need to be tested. But would you really want to call out the third-party API while we actually test it? This might actually make us difficult to test the Apex callouts. And I know everybody is trying to hear the word, where are the Garner limits around it? Yes, there are governor limits around Apex callouts, and we do not want to expose them at all. So how do we test Apex callout now? So let's talk about it. Do we have an option, first of all? Yes, do we? We do. HTTP MockCallout Interface to the rescue. So what is HTTP MockCallout? It's a built-in construct to simulate a response from the third-party API. It allows the test method to construct the HTTP request as well as the response. So when I say I'm constructing a response, that itself means that I'm creating a fake response without talking to the third-party API explicitly. So multiple mock classes can be created and can be referred in the test classes. Best thing, no need to leave the Salesforce domain. And always be under the governor limits. Let's see how the code actually works now. Here is a snippet of a code where we are actually trying to write a test class, where we have annotated it is test so that we know that the class that we are going to write is a test class. We have some test methods defined. We have some constructors defined here, and then we are trying to basically test the two methods that Sai actually showed in his code: get list by lat launch and get list by address. And we have given the parameters that we are searching for a restaurant. We have a latitude, longitude that is already set in, and we also have a string address to get us the best possible restaurants nearby. So what happens actually inside? So here we are trying to see that we are trying to create a response. When we create a response, we are mentioning what URL we are trying to reach, and we're actually asserting it against the endpoint. And also, we are finding out which method that we are trying to actually call it with. And finally, you read here, the response says that we are creating a fake response. All we need to do is, for this request, what is a sort of response that we are expecting? And we are trying to set it the same response with a header, with a body, and the status code. So this test case is very specific to a happy path. So think about you want to test a negative path where you know that calling that Apex callout is not returning back the result, but returning a 404 not found. So what would you do then? Basically, you would probably set your body to something called as description page not found, and your status code will be set to 404. So that's where you can test out different methods and different responses that you're expecting out of your Apex callout. Isn't this really cool? That testing out an Apex callout without actually making a call to the third-party API. So let's hear something similar and something more interesting from Sai for the next section. Thank you.
All right, so now that we know what a callout is, how to create a request, how to create a response, how to create a transaction to complete successfully, let's look at something interesting that is specific to callouts. Now, this is one of the features which actually would make callouts more accommodative for day-to-day operations. If there is a long-running callout, in other words, if you're invoking an external web service and it takes longer than your accounted time for governor limit, then you'd want to use something called as continuation. Let me quickly walk through what happens in the image below so that we all kind of understand the entire flow for continuation. So on the Visualforce page, a user invokes an action which calls an external web service. That is step one. Step one leads to your app server. That is where your code exists. From the app server, there's an invocation which is made to the continuation server. Again, continuation server is specific to asynchronous callouts. After step 2, if you look at step 3, the control comes back to your Visualforce page. Now, what happens behind the scenes is the continuation server is basically getting in touch with the external web service and doing the work for you. So step 4, it's trying to build that request, and then it's trying to contact the external web service that you might have mentioned in your HTTP request. And then step 6 is when a response is being received from the web service, and then the continuation server basically has to forward that response to your app server. Now at step 8, what the code should have is basically a way to handle the response that was initiated in step 1. What that is nothing but a callback method. So when you're doing step 2, you'd have already mentioned it in your request, in your continuation request, about what you want to do when you get a response from the external service. So at step 8, the service is going to find which callback method it needs to invoke to, and then basically the control would be back to your Visualforce page. Now what's fancy about this? Isn't this yet another Apex callout? It actually is not. With asynchronous callouts or a continuation, it doesn't count towards the Apex limit of 10 synchronous requests that last longer than 5 seconds. Let me give a good use case that we can all relate to. Let's say you're in a company which needs to verify product warranty information. You have 500 users who are getting calls asking about warranty information. So there's a possibility that any given time, there are at least 500 people trying to click on a button to verify your product warranty. In a regular callout, you'd run into a governor limit because you're restricted to only certain transactions in that set of time. With continuation, what you have on your side is you can actually queue these requests to your continuation server and then handle it gracefully without any issues. So you are in a situation where even though the platform doesn't expose asynchronous related items, this is one way of achieving that. Another feature that would be helpful is you can actually chain these callouts one after another. Let's continue with the example. Let's say we're getting the product warranty, and then we need to verify if that product is registered or not. So that can be another external web service. So you'd make a callout first to get the warranty information, and then from that response, you can chain another callout, another continuation. Basically, think about it as another set of flow that comes below this. That can be invoked. So the chaining can be achieved quite easily with very few lines of code. Another thing is you can actually have at least 3 parallel requests that is considered as a continuation. So at any given point of time, you can have at least 3 continuations going from your Salesforce organization. So this is one of the features which many companies need to consider because you're able to get what you need in a more elegant way with regard to callouts. With Apex, we always have limitations, and so do we in the case of callouts. With regard to the number of callouts per transaction, we are limited to a number of 100. The timeout, if you guys remember, we were setting it on the request, is defaulted to 10 seconds. So if we weren't doing the set timeout on the HTTP request, then it's going to default to 10 seconds. You also have an option of setting a custom timeout, which is limited between 1 millisecond to 120,000 milliseconds. Another important aspect with regard to callouts is you cannot have any pending transactions, pending operations within a callout in the case of a transaction. What that means is you cannot have an insert statement followed by a callout. The reason for that is you have, let's say you're inserting an account and then you're invoking a callout. Now what happens if the callout fails? You still have this data which was trying to get inserted still hanging. So the platform limits having pending operations followed by callouts. But what we can do is, in the case of MockCallouts, which we just saw, you can have that. You can have a DML followed by a callout because you're not going outside of your organization. And like I mentioned about the continuation limitations, the maximum number of parallel Apex callouts are limited to 3. And then the chained callouts, where you have one continuation attaching to another, can be done up to 3 values. So these are all the limitations. Even though these don't seem overwhelming, if used appropriately, we can actually make use of these features in the best possible way. We have some resources that we have referred to, which I'm sure will be handy for you guys as well. Just to quickly summarize, we went over what, how, and when to use Apex callouts. We did a quick demo about how we can incorporate callouts through a Lightning component easily into an account page. And then we looked at the limitations that are currently there in the platform, followed by the feature of continuation, which can be used in a good possible way. So that kind of summarizes our talk today. Thank you so much for joining us. Sagar and I would be hanging out here. So if you guys have any further questions, you want to discuss something specific, feel free to drop by. Thank you.
Thank you so much, guys, for joining us.